This evening we will be studying Unit 1.5, Graphical Transformations. Not to be confused with transformers. So while we talk about transformations, we are going to talk about them in terms of our basic parent functions. Here we have our basic parental quadratic. Just the basic quadratic f of x equals x squared. We are going to do a variety of things to this. Understand that we are using the x squared as our example function. The methodologies and the processes that we are going to be talking about can be applied to any of our parent functions, and in a broader sense, it can be applied to any function in general. As I go through this, I assume that you have the notes labeled as graphical transformations up in front of you, and the first transformation that we see is shifting up. So if we wanted to move this function up, shifting has absolutely no effect on the shape of the function. By adding 2 to the outside of the function, this is going to cause this function to move up 2 units. So we plug in to the same x values, and notice if we take that negative 2, square it, that gives us 4, then add 2 to it, that gives us 6. That is 2 more than it was there. But the difference between 4 and 1, that's 3. 3, that's 2 more than the 1, but notice the difference between 6 and 3 is still 3. The distance between 3 and 2 is 1. The distance from 2 to 3 is 1, and 3 to 6 is 3. So the shaping of this is the exact same as the shaping of that. Each point that we found on this graph, there is an equivalent point that is 2 points up. So the shape of the new graph is the exact same shape. Adding 2 shifts to the outside. Adding 2 to the outside shifts up. Subtracting 2 from the x squared is the same idea, only instead of shifting up, subtracting 2 will cause the function to shift down. So again, the basic shape of the function remains the exact same. The only difference is you are basically taking that blue function and just moving it down 2 units to make that purple function. So the g of x function, by subtracting 2 to the outside, is the exact same shape as the original function, only it is moved down. One thing that we want to take notice of is we are working vertically. When we do things to the outside of the function, we do things to the function and just add and subtract to the outside, and you'll see what I mean by to the outside in just a second. That causes vertical motion. Now, vertical motion goes in the direction you would expect. When you add 2, causes it to go up. When we subtracted 2, that caused it to go down. So we are going to continue working with this same parent function of x squared. But remember, when we go to do other problems, as you start doing your homework and things, the things that we're talking about here can and are definitely applied to all of the different functions that we are studying. So anyway, now we're going to look at some horizontal shifting. And we will start by looking at what happens if we take, and remember I told you that you would see what I meant by inside versus outside. So let's take this new function and we'll call it h of x, and we're going to go x minus 2 squared. So notice that this is what I mean when we go inside. So when we do things directly to the x, By doing something directly to the x, that is going to have a horizontal effect on the graph of this function. And it is horizontal acts opposite what you would think that it would do. And I will show you what I mean by that as we go. So let's start with h of 0. That would be 0 minus 2 squared, which would give us negative 2 squared, which is 4. If I plug in 1, that's going to give me 1 minus 2 squared, which would be negative 1 squared, which would be 1. If I plug in 2, we get 2 minus 2 squared, which is 0 squared, which is 0. You can continue to plug in that same fashion, and you will see that this is the table of values that you get. Now, when I go and I graph those, 1, 2, 3, 4, and then I've got 1, 1 still, and now I've got 2, 0, and I've got 3, 1, and then I've got 4, 4. We see that we still have that exact same shape in our new function as we expected, but by subtracting 2 from the x, it actually shifted the function to the right, not to the left. Now, to most people, that is opposite the way that you would think. Remember, when we added 2 to the outside, it shifted it up 2. And when we subtracted it, shifted it down, going the direction you would expect. Horizontal translations, and that is what this is called, is a translation, or it's called a shift. But horizontal shifts, they occur in the opposite direction that you would probably expect them to. Looking at g of x equals x plus 2, negative 4 plus 2 is negative 2. Negative 2 squared is 4. Negative 3 plus 2 is negative 1. Negative 1 squared is 1. Negative 2 plus 2 is 0. 0 squared is 0. Negative 1 plus 2 is 1. 1 squared is 1. 0 plus 2 squared is 4. So we see that there are our table of values. When we plug those in, exact same shape, but the graph is shifted to the left too. So subtracting to the argument of the function, that is the x, right? That's another word for that, is argument, right? So subtracting from the argument of the function has the result of shifting the function to the right. Adding to the argument of the function has the effect of shifting the function to the left. Now, everything that we just talked about, in the notes, it uses the word shift. But another word for that you're going to see later is translate, okay? So what we've talked about thus far, that is called translate. And translate is equivalent to shift. And the reason we're going to do that is just to get we'll see stretches and shrinks have an S. So translate. All right, what we've done just now is we translated up, translated down, translate left, translate right. When you translate, that is just moving the thing around without changing its orientation or its shape. It's also known as shifting. Next, we are going to look at reflection. And there are two types of reflections that we will have. reflection across the x-axis, also known as vertical reflection, and reflection across the y-axis, also known as horizontal reflection. So this time we will go ahead and look at the square root function. Like I said, any of our parent functions work with any of these, so so that we can see that. So let's reflect. Reflection occurs when we include a negative and add a negative either to the outside or the inside of the function. First of all, let's look at h of x is the negative square root of x. You're going to notice a couple of patterns. Whenever we do something to the outside of the function, remember when we translated, we added to the outside, it caused vertical motion. So whenever we do something to the outside, that is going to have a vertical effect. So this is going to cause us to reflect across the x-axis, which is horizontal, but when we reflect, it's going to cause a vertical reflection. Let's see what I'm talking about. I take my x, and in this case, I'm going to plug in my same values, 0, 1, 4, and 9. Now I take the square root of 0, then I make it negative. So the square root of 0 is 0, bam, still 0. Take the square root of 1, then I make it negative. Take the square root of 4, then I make it negative. Take the square root of 9, then I make it negative. So notice that all of these numbers that were positive have now become negative, but they still have the same basic shape. So what we end up with is that same shape, only instead of being above the x-axis, it is now below the x-axis. And notice that's why we call that a vertical reflection, because it flipped over vertically. If we now do the same type of thing, but we're going to add a negative and we're going to add it to the inside of the function. So we're going to say g of x is going to be the square root of negative x. So now we're doing this to the inside of the function rather than the outside. The first thing that you've got to notice there is that you can no longer plug in the same values. If I plug 1 in, I'm trying to take the square root of negative 1. I can still plug in 0. I get out 0. Instead of plugging in 1, I'm going to plug in negative 1. Negative negative makes positive, so the square root of negative 1 is 1. The square root of 1 is 1. All right, so g of negative 1 would be the square root of negative negative 1. Negative negative makes positive. That's where that 1 comes from. Same idea, negative 4 becomes 2, and negative 9 becomes 3. So now, by replacing the x with a negative x, we end up with the same shape, only instead of going this way, it's now going the opposite way.